Okay, 7.6, fundamental theorem of algebra. That makes you sound really fancy. But essentially, all that is just solving for roots or solving for x-intercepts when you're given a polynomial. And so there are different kinds of solutions, which we've already touched on a little bit. But we're going to be able to look at a polynomial function and decide how many roots, how many of those, and what types they are. So here are all the different options. If you have a rational root, what that means is any whole number or fraction. So any whole number or fraction is considered a rational root. Irrational means just any decimal that cannot be put into a fraction, and typically those are under a square root, so those are the ones that you have to solve for. You can even put to the side, decimal cannot be put into fraction. Multiple roots, so you'll see two types. A double root is whenever it bounces off the graph. So double root is when it bounces, it's not bounced, it bounces. And I think we may see one example of a triple root. But that would be, for example, if you had x minus 3 to the third, then x equals 3 would be a triple root. So if it's to the third. And then imaginary solutions are solutions with I in them. They do not cross the x-axis. So, let's say that you see a graph that's an x to the fifth graph, but your graph only touches the x-axis 1, 2, 3 times. So 1, 2, 3, but it's an x to the fifth. That would mean that you have 3 real solutions and you would have 2 imaginary because they don't show up. So if you have a high degree, but it only crosses the x-axis so many times, that means that the other remaining ones would be imaginary. Solutions are also called factors and roots. They also could be called x-intercepts. So I'm going to write that one in as well. So on number 1, how many solutions does x cubed plus 5x squared plus 4x plus 20 equals 0 have? And then what type are they? So the only way to decide what type they are is by actually graphing. But I can look at this and decide how many solutions they'll have based on the highest degree. So how many solutions does this have? 3. Now I want you to graph this in your calculator and tell me what type they are. So you get one rational because that is at x equals -5. And then that's the only time it crosses the x-axis. So that means that the other 2 must be what? Imaginary. Okay, number 2, graph number 2. How many solutions will it have? Okay, what type are they? I've got 2 rational. They are at x equals -1 and 3, which it only crosses twice, so that means that the other 2 must be imaginary. Okay, number 3, find all of the zeros. How many will there be? 5. So I want you to go ahead and graph that. And if I'm going to find all zeros, then if I want to reduce it to a quadratic, how many times will I need to do synthetic division? 3 times. So you should find 3 rational roots at least. So when you graph it, what whole numbers or fractions do you find when you graph? You get -1, and that's a multiplicity of 2 because why? Because it bounces off, so here it's going to bounce off, and then what is another one that you get? 2. So I have an x-intercept at -1 and +2. Another thing you could do, so if I'm sketching the graph, we know that it's an odd function. So my end behavior, if it's odd and positive, means that it's going to go up to the right and down to the left. It bounces off. So it's going to touch -1 and then come back down. Could I figure out a y-intercept from this? Maybe not using your calculator? How'd you get that? It's the last number. If you plugged in x equals 0 into this, you would end up getting -14. So it's going to come down here to -14 and then come back up and go through. Which you can look at your graph and kind of see that it looks that way as well. Yeah, you'll want to match the y-intercept. Okay, so if I'm going to solve this, then I'm going to use synthetic division. So -1, I'm going to list out my coefficients. So 1, -4, 4, 10, -13, and -14. Then I'm going to do -1 again, kind of running out of room. Oh no, what do I do? This is awful. 2 times 2. Okay, so along the bottom you should get 1, -4, and 7. So then it would be, if I have 1, -4, and 7, my quadratic would be what? X squared minus 4x plus 7 equals 0. And we know that they're going to be imaginary, so how do I solve if I know that the answer is going to be imaginary? I have to do the quadratic formula. Or I get to do it, I'm sorry. So x is equal to -b plus or minus square root b squared minus 4ac all over 2a. 16 minus 28 is -12. How do I simplify the square root of -12? And if you pull the 4 out, what does it become on the outside of the radical? So 4 plus or minus 2i square root 3 over 2. Can I simplify this any further? I can, indeed. I can reduce by 2 and 2 here. So 4 over 2 gives me 2 plus or minus. The 2's will cancel and it just becomes I square root 3. So I've got -1, multiplicity of 2, 2, and then 2 plus or minus I square root 3. Okay, so the last part is they're going to be now asking you to create or write a polynomial function in standard form, and they're going to give you the roots. So I think there's two parts of this that can be a little tricky. The first off is if they give you a square root or an imaginary. So if I said, like on number 5, it says 2 plus square root of 5 is a factor. Then, and they don't tell you anything else, you have to automatically assume that 2 minus square root of 5 is also a factor. So you have to add that in yourself. They don't tell you. You just have to know. I think on one of the examples it gives you an imaginary, maybe. Number 7, it gives you both of them. Like number 8. So if they said that, so if I said that square root of 5 was a factor, you would have to say negative square root of 5 is a factor. If I said that 2i was a factor, then you would have to say negative 2i is a factor. If I said that 3 plus I was a factor, actually, I'm going to switch it up. If I said 3 minus I was a factor, you would have to say 3 plus I is a factor. So basically, anytime you have a square root or an imaginary, when you're solving them, it makes sense because it's always plus or minus anytime that you're solving them out. But when you get a question like this, they're only going to give you one of them and you have to add in the other one. So you must add in its conjugate, which is what it's called. Must add in conjugate. So number 4, that one's easy, and I'm not going to make you FOIL it all out because that takes forever and we don't have time. So if it said and if it says write it in factored form, then you can just leave it in the parentheses. It gives me the x-intercepts as negative 1, 2, and 4. So the factored form, I'm going to take the opposite sign. It's going to be x plus 1, x minus 2, and x minus 4, and then I'm done. If it said write it in standard form, then that's when you've got to multiply it all out, do the whole shebang. But it said if it says factored form, then do it that way. If it says standard form, then multiply it all out, and I will specify for you. And I'll tell you right now, it's probably going to be standard form because these are just too easy. Okay, number 5. Nope, that's not an eraser. Okay, number 5, it says a leading coefficient of 1, which just means that you don't have to add in an a value in the front. And it has 3 and 2 plus 5 as zeros. That means I need to add in another 0, which would be 2 minus root 5. So I'm going to write it in factored form first. So x minus 3, x minus 2 plus root 5, and x minus 2 minus root 5. So I'm going to show you a shortcut with these that I think will save your life, but it's a little, you just got to stay with me. So I want you to put your pencil down, and I want you to just watch me do it first. These two, when you're foiling this out, these two parentheses right here are considered difference of squares. Where? Because difference of squares is like a plus b, a minus b. Is everyone following me with that? And it just becomes a squared minus b squared. Like if you FOILed it out. Kind of like x plus 3, x minus 3 becomes x squared minus 9. These two parentheses right here are the same thing. Where the plus and the minus come in right here. So x minus 2 plus root 5, x minus 2 minus root 5. Where x minus 2 is my a, and then root 5 is my b. Are y'all following me with that so far? So what I need to do, so my answer will be x minus 2 squared minus root 5 squared. So that's which is just 5. So that's what my answer ends up becoming because it is a difference of squares. So I need to square the x minus 2, which is just foiling it. So it becomes x squared minus 4x plus 4. So if you FOIL that out, get x squared minus 2x plus 4. And then combine like terms. I just do it in one step. But if you want to do it the long way, that's okay. Minus, and then square root of 5 just becomes 5. Then I simplify it, so x squared minus 4x minus 1. So then minus 5, then simplify, becomes x squared minus 4x minus 1. And then I still need to bring this down, and it becomes x minus 3. So I've got this. I'm still not done, though, because I need to simplify it even more by multiplying this out. So I'm going to FOIL, becomes x cubed minus 4x squared minus x minus 3x squared plus 12x plus 3. Then I combine my like terms. X cubed minus 7x squared plus 11x plus 3.